I think in the last class we studied about the first question that we had in the exam paper, the sample exam paper. So as I said before, like you can refer the sample exam paper and prepare for the exam. However, it might be the end exam paper might be different from this exam paper that I have provided to you. So in the exam paper that I have provided to you in the LMS, I have given you 4 questions, and in those 4 questions, I hope you can, go and check in the LMS the exam paper. Okay, so it's kind of I will share only the questions one by one in in today's whiteboard. Okay, so in the last class we discussed the first question, as I remember, right? If I'm not correct, you can let me know. Okay, if I miss something or some question, you can let me know, right? I will start with the second question in today's class. So I already have discussed this in the one of the lectures in previous classes. So therefore, I won't be taking time to explain in detail, because I have already done this question in a lecture in a previous lesson, in the tutorial, I mean, of a previous lecture. So you can, I think some of you who were in the class have already gone through this, and therefore there's no need to do the same thing again. So in this question, in the second question, they are focusing on the computing approaches that are useful for IoT scenarios. So in this question, basically, the question is asking um, you to design an IoT network that will be able to address the communication in a scenario where there's a lot of devices connected to the access point of the IoT network. So, uh, so uh, we are considering a certain IoT network which is deployed at a certain local area. Uh, and in this case, we are considering vehicles as the devices which are connected to the IoT network. So the vehicles have sensors in them, and those sensors enable the vehicles to give details such as the location of the vehicles, the fuel consumption of the vehicles, and the performance of the vehicle, and the amount of time it takes for the vehicle to get maintained, right? I mean, the vehicles need to be serviced, right? We need to service vehicles in a frequent manner. So once we need to do that, we need to take measurements from the vehicles to decide at what point we need to do such kind of a maintenance of the vehicle. All those things are basically depending on the sensors which are uh, already available in these vehicles. So the vehicles will have multiple sensors in them. So those vehicles will collect the data in from those sensors, and the embedded system that is available in the uh, in the in the vehicles will have the entire system, where the embedded system will have will be I mean will be having a collection of sensors connected to it, and those sensors will give different data, and the embedded system will do some processing, and it will communicate the data that it has collected, uh, and the decisions that it has gained to the access point of the IoT network. So in this case, we can assume that this application is run by a company, right? A separate company, like for example, Uber or PickMe. right? Let's take for example Pygmy, and the Pygmy company has a group of vehicles, and the group of vehicles are situated at a certain space in a certain area, and the sensors are having a communication features, and the sensor nodes are able to, are having communication features, and they communicate to a certain access point which is available in the environment, in a specific location in the environment. So let's say there's a router in the nearby area of the vehicles, and that router is collecting data frequently from the sensor nodes which are available in the vehicles, right? So the data are transmitted to the access point by different uh, I mean vehicles, and the data is transmitted from the embedded system that is installed in the vehicle. There could be like multiple vehicles, and the number of vehicles can reach up to n number of vehicles. There could be n number of vehicles. So depending on the situation, there will be massive number of vehicles. So massive number of vehicles will be connected to this access point in the local area. So in the local network, the local network which belongs to the Pygmy, for example. The access point that collects those data will be a certain router, and that router will be connected to another uh, router, and that router will be connected to another set of routers which constitute the public internet. Okay, so the company will connect to the public internet through a set of routers and switches, and after that the data which is collected in the router at the endpoint will be transmitted through the public internet to the destination node, where the data is either stored or accessed by some other person. So if Pygmy has a cloud server, then they will store the data that is collected in their networks in this cloud server, and any other external person can access this data if they have the authority to access the data from another location in the public internet. So, for example, company owner or someone can access the data from another location at his own office, and they can access the cloud server which is located maybe in another country or in some other place which is not exactly the office. This could be the network that will be used by the company. So this is the cloud server, right? So this is the kind of the common solution that can be applied for doing the computing in the network. Okay, so in this question, the question is asking us to select and design a specific type of computing solution for this application. So computing solution means like there are mainly three computing solutions that we discussed in the lecture, right? Can you remember those three types of computing? Can you let me know?
Fog compute,
Yeah, for computing, cloud computing, and
edge computing.
yeah. So there are mainly three computing technologies that are popular. So cloud computing, fog computing, and edge computing, right? So, what is the difference between these three computing technologies? Do you know?
Latency.
I mean, yeah, latency is different based on the computing technology you choose. Uh, but more than that, what is the difference between, I mean, what is the, I mean, what is the factor that makes them different?
In edge computing, the processing is done near to the sensors. It means near to the car. In
Mm-hmm.
computing, it's done in the middle position. In cloud computing, has to be all the data has to be transferred to the cloud, it means end device. Then processing is done at the cloud.
Yeah, so that's correct. So, like, that's a correct answer. So, the location, uh, data processing location is the factor that makes these computing approaches different. So, the location where the data processing is done is different in these three computing methods. Okay, so in cloud computing, the computing is done at a cloud server, which could be somewhere far away or remotely located from the edge point of the IoT network. And the fog computing is happening somewhere in between the cloud server and the edge server. Okay, so then the edge computing is happening at the edge of the network. So the edge of the network lies where uh, the boundary, where the access point and the sensor nodes uh, lie in the network. Okay, so in this case, like, the sensor nodes are located in the vehicles, and the communication, the data is communicated from the sensor nodes to the access point. So the local area network that consists of this router that collects the data, and the sensor nodes is considered as the edge of the network. So the computing that done at the edge of the network is known as the edge computing. So the edge computing can happen either in the sensor nodes, or else it can happen at the edge server, which is connected to this router. Right, so we can connect a server to the access point, and then at the access point we can do processing of the data. So in that case, we say that the edge computing is done at the edge server, right? So edge server also can do the computation in the edge computing. Also, the sensor nodes based embedded system can also do the edge computing. So uh, there are therefore, like, there are many methods to do edge computing, and many, I mean locations that we can do edge computing. So that is how the computing technologies are divided. So mainly there are three types of computing technologies. Okay, so based on this scenario that we are considering, where vehicles are connected to an access point, uh, and that access point is collecting data regarding vehicles, and those data getting transmitted across the from the router and across the public internet towards the cloud server. In that application, uh, uh, the uh, the application, I mean, the question is asking what is the cloud what is the computing technology, what is the application that you can choose to use a certain type of computing technology. Okay, so so I hope it is clear to you. First, you need to select a certain application which will use some type of a computing technology. So in this network, right, in this network, there are many applications that can use these computing technologies. So if we take applications, we can write mainly three applications. I mean, that I discussed before. You can come up with other applications as well. These are not the concrete applications for this scenario. So you can do location tracking of the vehicles, location tracking or location monitoring of the vehicles. So for that we can use like GPS sensors and other like location monitoring measurements to measure the location and track the location of the vehicle. Apart from that, the fuel efficiency uh, monitoring or fuel efficiency monitoring can be done. So these are the applications that we can focus uh, from our IoT network. Okay, so from our IoT network, these are the applications that we can try to achieve. These are the kind of services that we can try to achieve from our IoT network. Then we can also do predictive maintenance, uh, which means that we can predict the time at which we need to do the maintenance of the vehicle, predictive maintenance. Okay, so based on these applications, we need to select the type of computing technology. Okay, so in the first question I have asked, like, choose an application which needs some computing. So choose an application. This is not the exact question, but choose an application which needs a certain computing solution. Okay, which needs a computing solution. Needs a computing solution. So you need to select a certain application which needs the computing solution. That means which needs a certain IoT solution where the network will do some computing and will give some results. So you can choose an application like this that I have mentioned, and you can decide like this application requires uh, uh, some computing technology, and it requires that computing assistance. So you can decide some application which needs some computing done in that application. Then you need to just mention in that question, you can just mention the application that requires the computing capabilities. Then you can in the next question I have asked, like, evaluate the possibility of using cloud, edge and fog computing for this application. Discuss the advantage of each approach. Okay, so another question has been asked by a student regarding the exam paper. So for online students and the physical attending students, I think the exam paper will be same. However, based on the instructions given to me by the registrar office, I will decide whether I'm going to give different papers for the two types of students. Okay, so that I will announce if there's some change. Otherwise, in general, by default, the same exam paper will be given to both types of students. So the second question is about evaluating the possibility of using cloud, edge, and fog computing for this application. To discuss the advantages of each approach. So, so basically, you need to select the application, select one of the applications, and you need to discuss the possibility of using a certain computing technology out of cloud, edge, and sorry, you have to consider the possibility of using all the three computing technologies for this application. Okay, so you need to discuss about all these three computing technologies, and you need to discuss how it will be useful for this application. So in this case, you need to bring out the advantages of each of the computing technologies. Once you take so we will talk about cloud computing, for computing and edge computing. Or else we can start with edge computing. Edge computing for computing and cloud computing. Okay, so in edge computing, so what are the advantages of edge computing? Like once you consider all the three approaches, what is the special advantage of using edge computing? As you think, what is the special feature in edge computing?
It has the lowest latency.
Yeah, lowest latency. Why is that? Why is that?
Information, it means the processing is done at so close to the vehicles.
Mm-hmm. Yeah, it is done very close to the vehicle at the maybe access point or at the sensor node level, and therefore the time that requires for the transmission and the transmission to happen is very low. And if there's some update that is required, that update will also come within a very short time interval, and therefore the latency of the total communication will be lesser, right? Apart from that, like because of the latency reduction, we can get real-time updates from the edge computing approach. So if you want, if you want to get very quick updates regarding some kind of environment or regarding some kind of process in the environment, we can get that very quickly using this edge computing method. Are there any other advantages of edge computing? Okay, so I think you can search about it as well, and then you can uh, you can identify those ones. So basically, we can get real-time updates regarding certain environment. So in real time means like the latency will be very low. So real time updates is the kind of the advantage, but mainly it is due to having the low latency in the communication. So you can write it using maybe just one fact. So real time updates because of having low latency in the communications. And then also we can in situations where uh, where we cannot rely on the network connectivity, uh, the edge computing does not rely on network connectivity much. So that means like you connect to the network, but only up to the edge server. So your data does not need to go through the entire internet and up to the cloud server. So if there's some kind of link failure in the network, and if the public internet is not connected, or some kind of issues are there regarding the public internet, and you lose the internet connection, even then the edge computing will function because you only rely on the most closest access point, right? Do you agree with me? So if there's some loss in network connectivity, the edge computing will not be affected by that if the connectivity is reaching up to the access point. So the connectivity in the intermediate locations up to the cloud server does not really matter, as long as the connection up to the access point where the edge server is there is maintained. So sometimes if we rely on the public internet and the cloud computing, then we need to also be careful about the network connectivity between the routers and switches in the internet, and we need to fix the network failures or link failures that can occur using technologies in the network. So the network connectivity, the impact of network connectivity from end to end is lesser. So the challenge or the network losses or link losses that can happen in from end to end between end to end communication. End to end communication does not rely much on the internet connectivity, right? So it needs to connect to the internet at one point, but on internet connect, however, it does not have to connect uh, and always have the connectivity with the internet to do the rest of the processing in the network. So in fog computing and cloud computing, you need to connect to the internet, and then you need to connect to the relevant server which is doing the computing. So therefore in that case, if we lose the connectivity between maybe routers in the network, then in the public network, then we might lose the connection to the destination node. So if that happens, then we again face some problems related to latency, and we might not be able to give the updates on time, right? So this edge computing has these kind of advantages. If you have other suggestions, you can let me know. Then fog computing is done at the intermediate location. So therefore, like the processing can be happening in an intermediate location, right? Apart from that, like this happens at a server which has a lot of resources to do the computing. So it has high processing ability, high processing ability, uh, high processing ability, and can act instead of uh, therefore it can act as a substitute of for the cloud computer, right? Can act as a substitute for the cloud computer at certain application. Can act as a substitute for the cloud at some instances. Okay, so sometimes if we have large volumes of data in our IoT network, we might not be able to pass all of that through the public internet to the cloud server within a short time interval. If we want the data to be processed very fast, and if the edge server is not able to do the processing, then fog server can do the processing there. So the fog server is an server which is connected to an intermediate node in the public internet, and the processing can happen over at the fog server. So the processing ability at a fog server might be similar to the cloud server, and it can have like higher processing ability than the edge server. Okay, so I mean, this is not I mean always this might not be always correct, but this is one of the advantages of using fog server where we select a server which has more processing ability than our edge server. Okay, so I hope it is clear to you. Then we can do the computation at the fork server. So that is the advantage of that. We can rather than sending the data all through route up to the cloud server, we can do the processing up to a certain level at the fork server and get the necessary data within a low latency. So that latency can be reduced in this instance as well using fork server. So this latency will be higher than edge computing, but in this case, this latency will be lower than cloud computing latency. Okay, so the latency related to cloud computing might have a higher latency. So basically, like I cannot really like define an equation, but in general, once you compare the three technologies, we can say that since the locations are different where the computation is done, the latency for the communication will be the highest for the cloud computing and lowest for the edge computing. And in between latency value will be given or will be generated for the fog computing. So the fog computing will have the second highest latency. The edge computing will have the lowest latency, and the cloud computing will have the the highest latency. So basically, we can just just have some idea that the latency will vary like that between these three computing technologies. So fog computing is also a good substitute for cloud computing in scenarios where we cannot handle large volumes of data in our network, and we need to process those data as quickly as possible. So the fog computing can handle that. So cloud computing has the highest processing ability. So the cloud servers are provided by the cloud providers. So the cloud providers give us the resources to process the data with the highest processing capability, and therefore it has the highest processing ability, and this actually is giving us a lot of advantages in terms of giving accurate data regarding our data that we have sent to that server. So we can get some useful outputs, useful insights into our data, and using that we can make some good predictions regarding our network, and we can give like realistic and very accurate data to our customers and to our employees. So accurate data can be given using cloud computing. So the latency will be highest in that case. However, in terms of the accuracy of the data processing and the analysis of the data processing, the cloud computing can be good. Apart from that, what is the other kind of advantage in cloud computing mainly?
We can scale up and scale down the according to the demand.
Sorry, the storage, you mean?
Yes, storage, data storage can be scale up according to the demand. So
Yeah, so the storage can be managed flexibly based on the demand, right? So anyway, the cloud servers have higher storage than when compared to fork servers and edge servers. In terms of resources, the cloud servers are, having having much more storage space due to the high technology that is involved with the data centers that store these cloud servers. So the cloud servers are basically stored in data centers, for example, in countries like US, UK, and so on. The countries which hold these data centers and who own these data centers. So these companies, they have built these data centers with very powerful computers, and these powerful computers are able to keep these servers, and these servers can like do multiple tasks at the same time. So these resources are like basically like available in these specific locations uh, in the world, right? So I mean, fog servers also will have certain features like this, but specifically there are data centers that have the resources which are having which enable them to provide very fast and very good services in terms of providing cloud servers, right? So the centers provide cloud servers which are having high processing ability, and which have the high data management ability, and also data storage ability. So data storage also will be done in an optimal manner in the cloud servers. So in terms of resources, the cloud servers will have the highest resources in terms of storage and processing and management. So basically, those are the things that we can say regarding the advantages of the edge, fog, and cloud computing. So are there any more advantages that we can add here?
So what about cost?
Yeah, cost of implementation. So the cost of implementation, it depends on the infrastructure that we are using to implement these technologies. So as of now, cloud computing is the most popular technology that is in use as of now. However, like the fog computing is also used, but when you consider about the edge computing is uh, not much used by people. So therefore, as of now, the cost of implementation cannot be compared with the current implementations. But once we see the costs, generally, I think if if we use the cloud computing scenario allow us to in the cloud computing scenario, there's a cloud service provider. So the cloud service provider will give us a certain like a set of services, and to those services we need to pay a certain fee. So that fee uh, will be given to us, so that fee will include all the services that the cloud service provider will provide us. So those services will include something like security, data management, storage, everything. So the infrastructure will be provided by the cloud service provider. So the everything will be provided to us. In that case, like we we will pay something for all the infrastructure they provide us. Apart from that, we also can make changes to the cloud server and the cloud architecture. In the edge computing sometimes might not be run by a certain cloud service provider. If we decide to implement the edge server, then we need to put the cost. We need to invest on that server and the calculations done there at that server. So if we personally has to invest on this equipment, sometimes this might be edge computing might be costly. So depending on who is going to implement this, the computing cost might be different. So if so in the current situation, the cloud computers are owned by a certain cloud service provider that will be like Google, Amazon, and like Microsoft or some big company who's owning these cloud servers. So in that case, like if we are using cloud computing, we need to take their service. So since we won't be able to do the implementation by ourselves, and we do not have the resources to do that. So if we are going to like so the cost will depend on uh, who in what way we are going to implement this. If we are going to buy the service from them, the fee will be determined by them. So we cannot exactly say what is the cost of the total implementation in there. In the edge computing also, if it is given by as a service by a third party, then the fee will be lesser than if we implement it by our own self. So therefore, the cost of implementation of these three computing technologies depend on whether we are implementing it or whether we are getting that service from someone else, according to my knowledge. So therefore, the fee cannot be exactly, determined as, okay, the cloud computing is the most costly one and the edge computing is going to be the cheapest one, and so on. So what do you think about that? Do you think that edge computing is the cheapest one when we consider about the cloud computing? What are your ideas regarding that? Do you have? So I think basically my idea is that we cannot really consider the cost of implementation for the computing scenarios uh, because because we do not know who's going to implement that service. So if it is a third party, it will be determined by the third party, and if it is our own self, then our own company has to pay that money, and that money has to be invested by the our own company for hardware and software. So again, depending on the application, the hardware that is required will change, and also the software that we need to do the computation might change. So therefore, sometimes we cannot exactly compare the cost of implementation for the computing scenarios. So for the computing, that might be the case, but for the IoT networks, we might be able to, define the cost based on different factors. So we will get into that in a later. I think we discussed that during the classes. So depending on the hardware we use as the sensor nodes, and the hardware we use as the communication modules, the access points, and also any other networking technology we use, we might have to spend a lot for situations where we are using a lot of devices, and it also we also need to consider about other technologies that we are going to use in the IoT network and so on. So when we consider about IoT networks, the cost will depend in a different way. So we will, I think, discuss regarding that also in the next questions that we are going to discuss today. Okay, so with this, I'm going to stop the discussion of the second question. And in the third question, I have asked, like, establish a selection criteria to select the best computing approach, and uh, decide like what is the best computing approach for this application. So you need to decide, like a selection criteria to select the best computing approach. So the selection criteria means like you need to decide like the evaluation metrics of your application. So evaluation metrics of your application. So if you select one application, you need to consider that application, and based on that you need to decide what are the metrics you are going to select. So if you want to consider the location tracking application, you can take for example the latency of the location tracking and the accuracy of the location tracking as like two main evaluation metrics. So we will take these as two main evaluation metrics, and based on these evaluation metrics, in order for us to make the latency lower and accuracy higher, what is the we can take like this as one of the selection criteria. So we want to reduce the latency and increase the accuracy. So based on these two factors, we can select a certain computing technology to use in our application. Apart from that, we can also take into consideration other factors that I have given in the question. So data processing ability also we can consider. So whether the server has a higher data processing ability or not, the storage ability, so the connectivity, and data privacy. Again, I have given cost as well. So right, the cost of implementation. So so that again I think we had a discussion. So you can so there's no one answer to the cost question. Okay, so you can give your own answer and give a logical reason why you are saying it is costly or it is not costly, like that. So so resource availability. So under these factors, you can decide, you can say what is the level of data processing you need for this application. So for the location tracking application, we need do we need high data processing? You need to decide that. So if we need high data processing, we can say we need high data processing, but not too much data processing, we can say. So we can say medium. We can say medium if we want, or else low, whatever that you think you can decide. So if it is medium, then you might need to do processing not at the edge server, but at the fog server. So we can decide what level of data processing we need. So if we don't need high data processing done, then we can say I need low data processing for this location tracking application. And then storage. Do I need a lot of storage? Do I need to save all the information I receive at the server? Do I need high storage or not? So that also you can decide based on the application. So if I take this application, location tracking, since the vehicle's location are changing constantly, I might not need to save all the data, but some some important data might be needed to save. So depending on that, I will decide like I need like a medium level of storage. I will decide. So then the connectivity. So the connectivity in here is the network connectivity. So if some network connection failures happen, does this network gets affected? Does this application gets affected? Yes, it will get affected, right? So we need higher network connectivity. We need we cannot address link failures, or we cannot we need to avoid network failures as much as possible. So therefore network connectivity needs to be very good. So it needs to be high, let's say, and we want to avoid network failures. So we need to decide based on that what is the type of computing that we will select. Data privacy. So privacy of the data. So in here, basically privacy or security we can take. So the security and privacy of data must be maintained. So is the privacy of the data very important for us? That is the question that we have. So if we want secure data, then we need to say it is high. If not, we can say low. So we don't need to really secure the data. The data can be, accessed by anybody else. So if that is the case, then we can say low. But in this case, we will select medium. We don't need high security, but we might need a medium level of security. So that means we don't expose everything, but we do not also have resources to secure in a very sophisticated level or very high manner. But we will need some sort of secure mechanisms once we are transmitting the data. And then the cost of implementation. So cost of implementation of the technology, it again depends on so you can say it depends on the amount of devices. Devices depends on the number of devices connected to the network. Number of devices connected to the network, right? So if there are high number of devices connected to the network, then also we can decide, like we can tell that the certain type of computing has a high cost. So if the number of devices connected will be very high, then the sometimes the cost of transmitting the data from one end to another end will be high and under cloud computing. So you can decide which type of computing to use based on the number of devices connected, and you can consider the number of devices connected as in order to calculate the cost, right? So we will we will consider that fact. You can consider that factor, and you can develop some uh, argument regarding the cost. However, like once you take the resources that you'll be using, like the servers, the data processing ability of the servers will also affect in the cost. And the storage. So the ability for the servers to do some computation and the ability for the servers to do some storage will also affect the cost. So that also might need to be considered once you are deciding the cost, right? So you can consider those factors and decide the cost. And so the amount of cost that you can allocate for this application, you can decide, and you can say like I'm going to invest medium level of cost for this, and I will not spend too much on implementing this application. And then or else you can say low as well. I don't want to spend a lot of money. I will spend a very low amount of money on this, and based on that I will decide the amount of data processing that will be done, and the amount of storage I will do, and so on and so on. So the cost, once you decide the cost as low, then other factors also need to be updated accordingly. So the factors like storage, the data processing, management, those things must be I think updated based on the cost that you are willing to invest on this. So if the cost is low, then storage will also be low, and the processing will also be low. So likewise, based on the cost, you will have to compromise the other performance of the system. So then resources, I mean availability, resources availability. So at the edge computing, the resource level is very kind of lower than for computing and cloud computing. So do you need a lot of resources? That is what I'm asking here. So you might not need a very high level of resources to do the location tracking application. So you might just need to collect some data and update that data in a certain server. So therefore, you might not need a lot of resources to do that. So therefore, you can say the amount of resource required is low. So based on that, you can actually based on these criterias, you can conclude the selection criteria to select the best computing approach. Okay, so do you have any questions regarding this question?
Madam, the question is not clear. It means out of 3 computing methods, we have to select one. It means whether it is
Uh,
Pogo, Edge, cloud like, oh, otherwise this kind of location tracking, we have to select. It means one. The question is not clear, madam.
Okay, so the question is saying that you need to select the application and you need to select uh, the criteria that you want to maintain for that application to happen in a successful manner. And then based on the criteria, you need to select the computing approach.
Excuse me, madam, we can select any kind of application?
Any kind of application, but that application has to be relevant to this scenario that I have mentioned before. Like, can you remember, like we are talking about the like IoT of vehicles. You can select any other application. It doesn't need to be location tracking. Is it clear? Is it not clear?
I am not clear about criteria, madam. Between location tracking is can be considered as one criteria. So can
No,
you
location tracking is the application that we are trying to implement. The
yeah,
application.
application, yes.
This is the
Likewise,
application.
you may give us it means sample application example so we can manage.
I mean, in the question, I have given maybe 1 or 2 application examples. Those examples you can use as the application if you like, or else you can suggest your own application as well. And then based on that, you can do the rest of the criteria and then decide in the approach and so on. So application, I'm not going to decide, okay, this is the application you need to consider and you need to do the rest of the thing. You can select your own application based on the scenario and then you can decide the criteria. Is it not clear? So actually, this is a sample exam paper, right? So this is not the exam paper that I have finalized, but yeah, so I mean, uh, if you cannot understand this question, it's okay. So do you have any questions?
So real-time updates can be considered as another application
Real-time updates about what?
about it means if it is a vehicle, the real-time updates about its speed or like that. So we can consider that it as an application.
Yes.
Okay, madam.
Okay. So that application you need to decide. So real-time update of some kind of a feature like speed, you need to decide that first. Based on that, then you need to decide in order to reach that application, in order to um, implement that application, what are the critical things you need to maintain in your performance? In your performance, what are you going to what are the criteria that you need to maintain? So the criteria you can decide based on several factors. So the factors that you are going to consider will be latency. Like if you're considering latency, I think it would be one of the factors to consider, because if you're giving real-time speed values, then you need to consider the latency of your communication. The latency of your communication is one of the criteria. Is it clear to you?
Yes, madam. Thank you.
Okay. So then you just decide the criteria, what you need as factors in order to maintain your performance. After that, based on the factors and the amount of latency you need, for example, you decide the computing approach you select for your application. So it can be edge, or it could be fog, or it could be cloud. Out of these three, you can select which one is best for your application based on the criteria that you selected, that you decided. The criteria you decided earlier. In the criteria, you said that you need low latency. In that case, like what is the computing application, computing approach that has the lowest latency? You can select. So, however, if you are not only considering latency, if you are considering other factors also, then you need to consider those other factors also in order to decide the best computing technology out of these three. So once your criteria factors are increasing, then you need to optimally balance like what is the best technology for your application. So either you can select like some very critical factors, and then based on that you can select one type of computing. So I'm going to like erase this question. If you have questions, you can let me know. And then in the final part, I think in the last, in the fourth part, I have asked like based on the evaluation and the criteria, you have to select the appropriate computing solution for the application. So so I think we already discussed that. So I will write that question in here again. So based on the evaluation and the criteria that you have done in the first two sections, you need to select the best computing solution for the application. And then so you need to justify your reason why you are selecting a certain certain cloud or some kind of computing application. So you have selected certain criteria. So based on the application and the criteria that you have selected, you are going to select a certain computing solution. So you need to select out of maybe edge computing, fog computing, and like cloud computing. And based on the decision you have made, you need to justify how that decision will enable you to achieve the task that you are going to achieve. So the task that you are going to achieve depend on your application. So the decision that you have made, let's say you have chosen edge computing, so the decision you have made should be compatible with the objectives of your application. So objectives of your application may be to give as you said, the information like speed, like to give speed of vehicles with uh, with minimum latency. So with minimum latency in real time. So in that case, you can just justify with some reasons that the edge computing, for example, has the lowest latency due to the sensors being located very near to the server or the access point, sorry, computing location. So the sensors or the vehicles are located, vehicles with the sensors are located uh, close by to the computing location. So that you can mention. Located near to the computing server. So computing location. So therefore, a lowest latency can be expected in that situation. So even if we have large volumes of vehicles, then we can manage that if we can do the computation at the edge server, right? So large volumes of vehicles also can be addressed and addressed in the situation, since we are only going to give some data such as speed, right? We are not going to do some large calculations. We are only going to give some very small data update back to the network. So even if we connect a lot of vehicles to the network, we can get that feedback back from the network with low latency once we have edge computing, you can say. Okay, so is it clear to you? If it is not clear, you can let me know.
Yeah, madam.
Okay, so I will go to the next question. So the last question is about draw the IoT architecture that you proposed, including the relevant components, and label each component clearly. So you need to draw the architecture, including the vehicles with their sensors. Just mention the vehicles and just draw some sensors on top of them, and the access point, communication technology, and if it is a base station which is collecting the data, you can draw a base station, and then if it is a router, you can draw the router. So whatever it is, you can just draw some kind of access point here, which will collect the data from the IoT devices. So you need to mention the access point. You can mention there's some communication that is happening, so some data transmission from the vehicles to the access point, and then from there you can do the rest of the communication. If you know exactly they are communicating using cellular technology, you can mention that. Otherwise, if you are using Wi-Fi or something, if you know that technology, you can just mention that. Otherwise, you can mention that whether you are using wireless communication or wired communication. So you can just mention that technology, whether it's wired or wireless. And then after that, like if you're connecting to base station, for example, the base station will be connected to through wires to the like core network and its network, and then it will be connected to the internet through certain routers and switches, and then you will be connected to the internet. And then if you are using other types of computing technologies, you can mention those things in here. So if you are using cloud servers or something like that, you can mention. However, even if you do not use them, I think it's better if you can just mention about the cloud servers, Spock servers, and those things. No, but I think it's not good to mention. If you mention, I think it will be like part of your design as well. However, uh, I will also mention that later, but if you are using cloud computing, then you need to mention all these components. You need to mention about the cloud server. So if you are using cloud computing, you need to mention the cloud server, where it is. If you are using fog server, you need to mention fog server and where it is. If you are not using the cloud computing or edge computing, or sorry, fog computing and cloud computing, then you don't need to mention where the cloud server, fog server is. You can mention that there's internet in here. However, you might not need to mention these things, these servers, but essentially you need to mention that at the access point you have the server. So at the access point where you have the other control mechanisms happening, you have the server and you have the edge server there. So you need to mention that. So edge server, this is the core network. So the important elements that are required for your application, you need to mention. So after that, another thing I want to mention was hybrid computing. So in some situations, you will make a mix of computing methods. So if you have the need to use two types of computing, you can mention that also, and you can say I need both edge computing and fog computing to do my application, to improve my application and conduct my application with a successful performance. So if you want, you can do a mix of computing. You can say what type of computing you are going to use in this. So that is kind of something you can consider, but it's not a necessity that you use that. So I'm just suggesting you can mention hybrid computing in cases where you feel that the edge computing might not be enough to achieve all the outputs that you want from your network. In that case, you might need to use another type of computing as well as support for your computing. So I hope it was okay to you. So again, one thing I want to mention is that if you are very logical with your answers, I will give marks to your answers. Right? Whatever you write, give reasons why you are making that decision, and then I will give marks to that, because that is what I'm going to evaluate. And therefore, there's no one specific answer to these questions. So if your friend has written, okay, edge computing is the best, it is not the answer. Like, it is not the only answer. There could be other answers that we can propose for this scenario. And if your answer is logical, I will give marks to that. Do you have any questions?
Excuse me, ma'am.
Yes.
Can you please explain again, for the edge computer, until where we need to draw the architecture?
So for edge computing, basically up to the edge server, we will need the architecture. So you can draw up to this point. However, since I was thinking, since we are considering IoT as our module, you might need to mention this public internet as well, right? So you do not need cloud computing, but you don't need these sections. Basically, this network architecture will be enough. Is it enough? Is it clear to you?
Yes, it's clear. Yeah.
Okay. Thank you. So I will move to the next question. So in the next question, I have asked about the industrial IoT networks. So in industrial IoT networks, like I have discussed about two types of, standards, Industrial 3.0 and Industrial 4.0. So in cases where we have Industry 3.0, we might need to improve that situation up to the performance of Industry 4.0. So in that case, like this question is asking about what is the difference between 3.0 and 4.0 in terms of handling large volumes of data and massively connected networks. So as you think, what is the network that can handle large volumes of data and massively connected networks? What is the standard that will address that? So I discussed regarding industrial IoT in last class. So I think you can go over that section, and you can refer the section theory related to that. So basically, the Industry 4.0 is regarding um, adding connectivity to the industrial facilities. So Industry 3.0, however, is about using computer systems. So Industry 3.0 standards was focused on using computer systems mainly to improve the efficiency of the industrial environment. Industrial 4.0 was focusing on adding connectivity to the industrial facility. So something very related to this module, which is the Internet of Things. So I mean, adding connectivity to the industrial scenario was the target of Industry 4.0. Therefore, Internet of Things comes under the Industry 4.0 standards, and implementing Internet of Things is one of the objectives of the Industry 4.0 standard. So once we are trying to handle large volumes of data, and once we are trying to handle massively connected networks, then since we are talking about connectivity and implementing connectivity in our networks in the Industry 4.0 option, then I think Industry 4.0 will enable us to handle large amounts of data and enable us to handle the massively connected networks. So since I think we discussed in our previous question also about massively connected networks, I'm not going to explain using diagrams, but you can explain in your answer that Industry 4.0 is focusing about connectivity and adding connectivity to the industrial environments. And in there, the connectivity is bringing connectivity between devices, connectivity between infrastructure. So in that case, therefore, like this Industrial 4.0 standard has been built to address the connectivity and implement the connectivity between devices and between infrastructure in industries. So Industry 4.0 has more capability to handle the connectivity and handle the issues that are coming with the connectivity in the industrial communications. However, Industry 3.0 is also having, computer systems. However, it also has some sort of ability to connect to like a local processing unit and so on. I mean, it has connections between the sensors and the processing units. Okay, so sensors, processing units have connections, and there's a central processing unit. So, I mean, if you take as an example, there are sensors. And these sensors are getting or transmitting their data to something like the programmable logic controllers, like PLCs, and then the PLCs are doing the processing at their level, and then the process data is sent to the central processing unit, which is located in a local network area, in the local area of the industry. So the central processing unit might be available in the industrial facility. In the industrial facility, this central processing unit will be there. Okay, so and also this data might not be shared with anybody else in the internet, right? So the data might not be shared with the internet, and not shared with the internet. So that is the situation that we have in current industrial scenarios. In traditional industrial scenarios, we do not share our data into the internet. We do not want to share the data in public networks. So, however, like as a solution to all that, the Industry 4.0 has come up with solutions to securing the data in networks where the networks are connected to the internet. Okay, so and also the networks are connected to the to each other. So connectivity with the internet is also available. So therefore, like in Industry 4.0, the data is communicated through the internet to a remote location where the data is processed and stored, and the data can be analyzed, and large amount of data can be managed. So you can mention like Industry 4.0 is focusing more on connectivity and to also allow the data to be connected to clouds computing locations, and it allows to process large amounts of data uh, due to the availability of resources to do computing. And it also allows us to connect large amount of devices at one time, and also the communication speed can be maintained above a certain threshold, and the communication can be done kind of in a reliable manner. Because of the availability of technologies such as internet, such as networking technologies like software-defined networking and network function virtualization and so on. So because of the technologies that come up with the IoT, we are now able to connect the devices in the industries, and we are able to handle the large amount of data that is coming up with the uh, with the connectivity, and also at the industry uh, uh, the data that is getting collected can be managed. So I hope you can mention that in this question. Apart from that, in the second part, you are asked to design a system, an IoT network with Industry 4.0 standards, and you are just asked to label the architecture and so on. So again, I will not draw that architecture. The same architecture you can use that I have drawn for the previous. No, but there are some differences. So I will try to show you. Okay, so in the industrial scenarios, we are actually working with different sensors than what we had in the normal IoT networks. So if we take sensors, we have big types of sensors, temperature sensors and pressure sensors and so on. There are, sensors which are large in size and robust in nature, and these sensors are connected to a central like processing unit, which we will call as PLCs. So number of sensors will be connected to this PLC. Apart from that, different types of sensors will be connected. Different types of input devices will be connected to this PLC. So there could be user interfaces like computers and some other like processing devices will be connected to this PLC. Also, the PLC could be connected to other devices like robots. So robots also could be maybe connected to this PLC through wired connection. Or right. So I mean, through wired connection, the robots also could be connected to this PLC. And all this data will be processed in the PLC, and the PLC will be the kind of the embedded system that will be processing the data. Okay, so it is the unit that act as the controller and the data processing unit. So the processing will be done in here. So the PLC has to be programmed earlier, and the data that goes in there will follow a certain set of codes, and that the processing will be done according to the program that has been written inside this PLC. Apart from that, currently PLCs are working with the Arduino and Raspberry processors. So therefore, in those situations, the PLCs are able to use the languages such as the Python, C to program the PLC. So therefore, now we can use easy programming languages to program PLCs. Earlier, we had to use a specific programming language like ladder, for example, to program the PLC. So in that case, we need to use a specific programming language. However, after programming the PLC, we are able to like get the processing done at the PLC. After that, the PLC will send that data that it has collected to a maybe central processing unit, or if we are using so maybe there are multiple PLCs which are in the industrial environment. So all these PLCs might send the data to a certain central unit, or we can say the data will be sent to a certain access point through wireless connection, and the server is connected to the access point. So we can send the data of the PLCs to the access point in the network in the industrial facility. So we will have multiple PLCs. So all these PLCs will be sending their data to a certain access point in the facility. So we will take this is the router. So this router could be in a certain local area, and then this router will be connected to a certain server, which will be collecting all the data of the network in this local network. So there we will be doing the calculations that is required, and apart from that, this router will also be connected to other routers, and it will eventually connect to the public internet. So the public internet will consist of routers and switches, and that will enable us to reach another location in the network, and that location could be another like industrial environment, or else it could be the cloud server that collect all the data regarding this industry. So we will think that this is the cloud server, and we will draw the cloud server here, and the cloud server that collect data regarding this environment. Okay, collect the data regarding this this industrial scenario. So the data will be collected there. so if there are other facilities also that are connected that related to this same industry, related to this same company, they will also send all the data to the cloud server. So the cloud server can process that data. So basically, this is the Industrial 4.0 architecture, where the difference is that we are connecting our industrial environment to the internet, and then we are doing the processing maybe in the cloud servers. Okay, so we have the access to the internet. Also, another important thing I did not mention is that the devices also have the ability to connect with each other. So if with each of their we can take different types of connectivity. It's very complex actually once we consider that. So we can have connectivity between two types of the same type of sensors, or else we can have connectivity between different types of sensors. So anyway, we are trying to, our ultimate goal is to create connectivity between each and every device in the industry. So we will say that the communication is implemented such that each of the devices can connect within each other as well. Okay, so connectivity between devices is possible in Industry 4.0, and connectivity with the internet is possible with the Industry 4.0. And once you connect with the industry means, internet means you can connect with another industry. So there's another industrial facility which has the same architecture, and we can connect our infrastructure with that industry's infrastructure. So we can connect with that industry as well through the internet. So therefore, like infrastructure to infrastructure connectivity is also possible. So this, if we consider this is one of the industrial infrastructure one, we will say infrastructure one, we will say. So if we implement the Industrial 4.0, we are able to connect infrastructure 1 with the infrastructure 2, and so on. We can connect with multiple infrastructures. So infrastructure 1 can be connected to infrastructure 2. So it will go through the internet and we connect with the other infrastructures. So so that is basically the concept of Industrial 4.0. So do you have any questions? So is it not clear to you? So if possible, if you do not understand, you can let me know. Okay, I will try to cover the next question. So you need to describe an enabling technology that will enable the industrial IoT networks, and justify how it will benefit the manufacturing facility and its owners. So enabling technologies, IoT enabling technologies. So we talked about mainly I think 5 technologies. So you can mention one of those technologies and mention how that technology will benefit the industrial IoT network. So basically you have technologies such as machine learning, cyber security, computing technologies, data mining, computing technologies, data mining, and so on. So basically, I think I mentioned to you mainly 5 types of enabling technologies. So in their 5 types, I mentioned edge computing and cloud computing as 2 factors. So that is why I only have 4 factors in here. So basically, you can mention that you can use one of these technologies in your industry scenario, and if you use that technology, what is the advantage and how it will benefit the industry. Uh, you can explain. So I think you can do that because I already mentioned that in the class. So you can do that. So apart then in the next question, I'm asking about uh, explain you will how you explain a challenge that you will face in this scenario. Explain potential challenges that you will face in this design that you have proposed. Right. So we are asking basically this question is asking about your proposed IoT system design. So because of that, once you are discussing this answer to this question, you might need to consider your specific design and say like what are the potential challenges that could come in your design, right? So in the potential challenges, you can write challenges like cybersecurity, right? So in order for you to like uh, in order I mean in this internet of things, you need to uh, you need to secure your data because you're sending the data through the internet, so anybody else can access your data. However, like because of the current trends and current technology, even that is challenging thing. So even if you add a lot of security to your data, sometimes the cyber security must be enhanced. So you need to you can say that cybersecurity is one challenge that is still existing in industrial networks, and that cannot be solved in some situations due to the uh, presence of many cyber attack systems. And we also need a new hardware software to implement the new architecture, right? So we need a new hardware and software to implement this new architecture. So this also can be a challenge to us because we need to buy those things, and the cost of implementation could go high with that. Apart from that, the expertise of people, uh, uh, I mean, availability of expertise is less. So availability of people who are able to handle these kind of networks is low, right? So therefore, availability of people who are highly skilled is low. So therefore, we might not be able to implement this network with flexible, with very, with ease. Then data integration. So data integration means like uh, once we are collecting different types of data and large amounts of data, then if we might face difficulties in managing our data. So therefore, in order for us to manage the data, we might face some challenges. So this could be a challenge, and we might not be able to we might not be able to integrate different types of data and different types of technologies. So this could be a challenge. So that also you can mention. So with that, I think I have discussed the third question. After that, I have the last question. So last question I already discussed with you in a previous lecture. So you can go through that, and uh, you can uh, you can get your uh, ideas on how to address that question using that lectures. So that's all about the exam paper. Okay. So I think I was not able to cover the machine learning for IoT part in this lecture. So this like a additional part that I'm doing for this module. I don't think that it is going to be a major section that you need to know. However, I will be covering it for the regular students. So if possible, you can go to their lecture video and get that information from that video. Okay, is it okay with you, or you want me to I mean, I can also upload a separate video on that and upload. So,
Madam,
Madam
excuse me,
has
any possibilities in that section
sorry,
coming to the
possibilities
any
means to the end exam.
yeah.
So actually, I have already discussed about the machine learning as a enabling technology for the industrial IoT networks. So in there, I covered a little bit about machine learning. I think that is enough for you to answer the end exam. So uh, the part that I'm going to do as machine learning for IoT will also contain the same content that I have covered earlier. So therefore, I don't think it's. I mean, you will have a separate question on machine learning in the end exam. I don't think. Right. So machine learning is just a enabling technology for IoT, not like one of the main technologies of IoT. Therefore, for the end exam, there won't be like a separate question on machine learning. But you might need to explain about machine learning in one of the questions that you are attempting. And for example, in the industrial IoT networks or in the general IoT applications questions uh, and any other question. Okay. Is it clear to you? Is it okay?
Yes.
Do you have other questions related to in the IoT content or the exam?
Madam, has last lecture been uploaded to the LMS?
Did I not upload it? Is it not there?
Yeah, it seems it's not there, madam.
Uh-huh. Okay, I will check. Okay, I can't remember actually. I will check, and if it is not uploaded, I will upload it. So in the last class we discussed industrial IoT, right? Industrial IoT. Actually, I can't remember because I'm doing two classes and I can't remember at what point I stopped. Can you remember what I did in the last class? All right. So anyway, I will check. I will anyway check. I will upload. Right. In the last class, I think we did on. I have all the videos with me. I will upload that. So you can refer that. So for the exam, do you have any other challenges? I mean, do you have any complaints regarding the lecture materials or lecture content or something?
Madam, we think that it's very easy for us to study. It means if there are PDFs are available, when it comes to exam
Yeah.
before the examination day, so we can just go
Mm.
go
Yeah.
reading PDF. If there
Yeah.
is possibility, could you please update it?
Yeah. Okay. So I will try to think about it. Okay. So I think other students also mentioned something similar to me. So I will upload them. I will do it as soon as possible. Actually, in my like last months, I was having other like very kind of busy. I had a busy schedule because of my own work and these lectures. So I was not able to upload all the things because I'm doing for many classes at the same time in the same week, uploading videos, uploading presentations, uploading assignments, quizzes. This has been not like optimal for me. That is why I have uploaded only the video. But I have asked you to write notes, and I hope you have done it because it is anyway efficient if you write it on your own. Only then you can, I think, get a good. I mean, a very I don't know. I mean, very efficient way of memorizing the content. But anyway, I will upload the content as soon as I can. Until then, you can have your own short summary of the content covered so far, and you can. I mean, I will upload the resources, and from that also you can get some updates, and you can prepare. However, the end exam will be closed book one. So, do you have any questions regarding that? Closed book exam. It's okay with you, right? Is there any person who's having problems regarding that? Apart from you not being able to come physically to the SLTC, I mean, one student or two students, I think they have that question. But apart from that, do you have any objection regarding closed book exams? Right. So if you don't have questions, that's good, because now currently we are not doing any open book exams from this semester onwards. So it had been decided by the SLTC admin and the department heads. So we are going to go ahead with the closed book. So therefore, prepare for that. So I will upload. I will also upload the submission link for your IoT projects in the LMS, and you can upload the projects there. Right. So with that, I will end today's class. So if you have any questions, you can ask. Otherwise, you can leave if you